Okay, first we're going to graph from standard form of a quadratic. Standard form, remember, is ax squared plus bx plus c. When I'm graphing from standard form, the very first thing I'm going to do is find the vertex. And if you remember, the x value of the vertex comes from the little equation negative b over 2a, or the opposite of b over 2a. So if I look, 2 is b, so I'm going to fill in what I know. Negative 2 is b, and 2 times a is going to be 2 times 1/2. 2 times 1/2 is 1. So the x value of my vertex is going to be negative 2. To find the y value, I need to plug back in. So I'm going to plug in negative 2 for x. Negative 2 squared is a positive 4, so I'm doing exponents first. Positive 4, 4 times 1/2 is going to be 2. 2 times negative 2 is negative 4, plus 4. 2 minus 4 is negative 2. Negative 2 plus 4 equals 2. So my vertex is at negative 2, 2. Move this over here. And now I need some other points. And if I don't know any other points, I'm going to need to use a table of values. A table of values can be useful for graphing in any form of a quadratic. What I do need to do is make sure that I put the vertex in the center of the table of values. It always goes in the center. And then I'm going to choose two values that are, let's see, I want to go the other direction, that are less than the vertex, the x value of the vertex, and two values that are greater than the x value of the vertex. And I'm going to plug in to find out what the y values are. So first we have 1/2 times negative 1 squared plus 2 times negative 1 plus 4. Negative 1 squared is 1. Half of 1 is 1/2 minus 2 plus 4. 1/2 minus 2 is going to be negative 3 over 2 plus 4. And if I think about a common denominator, 4 is equal to 8 over 2. So I'm going to get 5 over 2 when I combine the numerators and keep the denominator. This would be a no calculator problem, so I need to be able to do this down below on my paper. And I know there's symmetry in parabolas, so I also know that for negative 3, it's also going to be 5 over 2, or 2.5. Okay, let's shrink this again. And then I'm going to need to do one more calculation. This one's easy. If I plug in a 0 in for x, I'm going to get 4. So I know enough points now to be able to graph my parabola. You will probably be using graph paper, and I would be too, except I haven't figured out how to do that on here yet. So my vertex is at negative 2, positive 2. Then I have the point negative 1, 5 over 2, and 5 over 2 is the same as 2.5. Put those 2 points on here. And then I have the point 0, 4. And I have the point negative 4, 4. And that's enough to be able to draw an accurate graph across the grid that I have drawn. Remember to keep your graph accurate across the entire grid. Next, we're going to graph from vertex form. And this is a little bit easier because I know the vertex right away. It comes from the h and the k in the function. So I know my vertex is positive 4, positive 1. And then I'm going to go right away to start making my table of values. Again, the vertex goes in the middle. And I want a couple values smaller and a couple values bigger to be able to see the full picture. And then I'm just going to work on plugging in. So if I plug in 2 minus 4 is negative 2. Negative 2 squared is positive 4. 4 times 2 is 8. 8 plus 1 is 9. So I know that this is going to be 9. And using symmetry, if I plug in a 6, I should expect to get 9 as well. And then if I plug in 3, 3 minus negative 4 is negative 1. Negative 1 squared is positive 1. 1 times 2 is 2. 2 plus 1 is 3. And I have enough points now to be able to graph my function. And so there's our parabola. Okay, we've got one more to go. We've got from factored form. And from factored form, we can get the roots right away. So I know that my roots are x equals 2 and x equals negative 3, and that comes directly from my two factors if I were to set them equal to 0 and solve. I also know that I have a reflection, and I've got a compression, vertical compression by a factor of 1/2. I can set up my grid already. And I'm going to plot my 2 points. So I have positive 2 and negative 3 as my two zeros. And the next thing I'm going to want to do is find the vertex. And the way that I find the vertex is I'm going to average the two roots. So averaging is where we add them up and divide by 2. And that's going to give me negative 1/2. So I know I'm thinking of an x value at negative 1/2. And I'm going to plug in to find out what the y value of the vertex is going to be. So negative 1/2 minus 2 is negative 2.5, which is negative 5/2. And negative 1/2 plus 3 is positive 2.5, which is going to be positive 5/2. And so a negative times a negative is positive. We're going to get 25/8. And I know 24/8 is positive 3. So that's going to give us 3 1/8 as the y value of the vertex. So our vertex is negative 1/2, 3 1/8. And that's going to give me enough to get a good estimate on my graph of where the vertex should be. It's a little difficult to be accurate on this thing. And then because my grid goes further, I would definitely want to go ahead and calculate a couple other points and make sure that my graph is going to be accurate even down here until I get off of the grid. In this video, I'm going to demonstrate factoring by grouping. This is a cubic function because the highest degree of any of the terms is 3, so the degree of the polynomial is 3. And whenever I have 4 terms and I want to factor, I'm automatically going to try to go ahead and fit everything into the box. Sometimes this works and sometimes it doesn't. So I'm going to go ahead and just stick everything in here just as I see it. And then I'm going to work on factoring. If I look at the top row, the GCF is 5x squared. If this is 5x squared, the top has to be an x, and this one has to be a negative 2. And if this is x, this has to be a 3, and if I double check, 3 times 2 is negative 6, so everything in the box works out. So my factored form is 5x squared plus 3 times x minus 2. And again, that's factoring by grouping, and it sometimes is a good method to use if you have 4 terms. That's always what I'm going to try when I have 4 terms.